Welcome back. For this video, we're going to show you how to calculate various equations for linear models. We'll start out with a cost equation for our new solar panel recharger. First I'm going to do is start with a blank Excel spreadsheet. I'm going to put my view up to 120%. That's not that important. It just makes it easier for you to see. And I'm going to think forwardly and maybe make my columns a little bit wider here. So what we are going to do is take 2 points from data that we might have collected. And the first one is going to be the number of units, which is X. And the second is total cost, which will be our Y coordinate. At 40 units, our total cost is $950. At 100 units, our total cost is $1,775. I'm going to right justify the titles for clarity. Now, most of you, I hope, may recall the formula for slope, rise over run. And I'm going to work that out very quickly. The rise is y2, the second y coordinate over y1, and that's going to equal the difference between the B2 and B3. Might as well be consistent and put my formulas in column C as I have been doing all along. And then x2 minus x1 is going to be the difference between A3 minus A2. Don't worry about the formatting. And then to find the slope, we simply find the first value in B5 divided by B6, rise over run. That gives us our slope to be $13.25. I'm sorry, $13.75. Another way to look at this is our slope is our variable cost. Maybe we'll also label that variable cost. Now, to find the fixed cost, we need to find the intercept. And don't get too terribly worried about these formulas. This is mostly to relate what I'm going to do visually to something that you might be familiar with. Now for the slope, I'm going to get right to the formula. The slope is going to be equal to, the intercept is going to be equal to the slope that we just found times, we'll just use the first set of coordinates for 40 units, the y value of 950 minus the product of the slope times the 40 units, $400. So and that of course becomes our fixed cost. And then our total cost is equal to, get rid of that apostrophe and put an equal sign in there. Our total cost is equal to $13.75 for every unit plus $400. Now, if you thought that was a lot of work, let's try the following. Let's highlight the units cost and the total cost from A1 to B4. We need an extra row here. And then what I'm going to do with that, I am going to go to Insert, just a simple scatter plot. I'm just going to click right on it. Notice how it gives me my total cost Y based on a function of X. Now here is where the magic happens. If I click on one of the points, they both get, we'll call it excited. And then if I right click on that and add a trend line, that's the key, add trend line. Highlight the points, add a trend line. Linear is just fine. I need to slide down here to display the equation on the chart. And there it is. Y total cost equals 13.75 times X plus 400. Now let's try that a little bit different way. I'm going to go down, slide down to a new screen because I want to keep this all together. And in fact, now that I've done such a good job here, I'm going to save this. And I'm going to save this as on my desktop as linear functions, or linear models, I should say. And we'll refer back to it. So I'm going to make another set of points. Units again is going to be X. Total cost is going to be Y. This time I'm going to go increments of 20, 40, 60, 80, 100. And I'm going to use cost figures that are a little bit different. For 40, use 925. And then for 60, 1300. For 80, 1,450. And then for 100, 1,775. Right, justify those numbers. And now I'm going to highlight that again. Because I've got more than 2 rows, I don't need to have that extra row like I had before up here. I can insert another scatter plot. Notice that they line up pretty nicely, but they don't line up perfectly, which is okay because in the real world it doesn't line up perfectly. Highlight one or click on one and they all are highlighted. Right click, add another trend line, scroll down to find that equation. And now I have an equation of 13.5x plus 417.5. And that is called the line of best fit. So in the first example, we found the exact equation that met those 2 points. Here, I'm doing an estimated line of best fit, which is probably more realistic when you have several sets of coordinates based on various data that you might have, and just want to see if there's a nice, smooth linear equation. Now, the other point here before we end is that while it's not a perfect fit, it's really good. And if anybody is familiar with an R-squared value, if I add that, the R-squared value is almost 1, or in this case, almost 98%, which is really good. 100% would be the best. So that's just a quick look. I'm going to save, and we're going to take what we worked here and move on to another model in the next video.